Okay. Now we're going to number 6, Osmo Systems, Zach Stein. Zach.
Good luck. Thanks very much. Hello, everyone. My name is Zach Stein. I come here from San Francisco, California, and I'm CEO of Osmo Systems. And at my company, we are reimagining water quality sensors for aquaculture with the goal of bringing all aquaculture ponds and tanks online, recording water quality in real time. So the problem we're working to fix is pretty simple. Lost yields due to unpredictable changes in water quality. So this is a DO crash, a pH swing, or an ammonia spike. It's a big problem for farmers. And so that's what we do. And so today, I would actually like to focus on our story of how we got to aquaculture, because we didn't start there. And because I think it highlights a lot of the advantages and opportunities in aquaculture and its importance in the seafood industry. And then I want to also talk about why we believe building a data layer within aquaculture is going to be so important to the future of sustainable seafood. So I always like to start with our mission. This is where we are today. Our mission at Osmo Systems is to build technology that enables aquaculture to outcompete large-scale wild trawling in terms of taste, health, sustainability, and most importantly, price. So as I said, we didn't actually start in this industry. We started using our sensor technology in my background, which is in hydroponics and indoor farming. And it was actually in the middle of 2016 that we started getting interest from some large-scale shrimp farms. And we said to ourselves, okay, this is something that we should look into. So we started digging. And this was one of the first graphs that we came across. This should look pretty familiar to this audience. This is the UN data on fishing, our fishing statistics. And there's two stories that really stood out to us with this graph. And the first is that we are pulling out 6 times more seafood from the ocean than we were in 1950. And the second is that this trend, it looks like it's not going anywhere with the rise of middle class of seafood-loving countries like China. And so for us, this was kind of the picture of insustainability. Right now, for every 5 fish we're pulling out of the ocean for major species, only 1 is being replaced by wild species. This puts the kind of the tipping point for those species, the large ones, at 2048. It's coming. And so if we're going to achieve the UN goals around a sustainable food system, healthy industry, and protecting our oceans, we don't need this trend to flatline. We need it to actually start going down. So that led us to start looking at aquaculture. This, again, should be a very familiar graph. And we were really surprised. We were like, oh my God, aquaculture is already producing over half of the seafood that we eat today. And we dug into it further, and it's been the fastest growing industry in all of agriculture. It's pretty crazy. It generated $165 billion at the farm gate. And what was very interesting for us is when we usually think about aquaculture, at least us in the West, we imagine a salmon pen. And most of aquaculture is actually done on land, and it's done in controlled systems, which means that you have to control for water quality, which was pretty exciting for us. And so what finally pushed it over the edge is when my co-founder and I were asked by one of the largest shrimp farms in Vietnam. They said, hey, this looks super interesting. We've been looking for this for the past couple of years. You guys should come out. Oh, and by the way, how quickly could you deliver on 10,000 units? So we're still working on that last part. But when we were out there, it started exposing us to this industry. And we not only visited this farm, this is a $300 million facility. We visited the mom and pop farm next door. And since then, we've visited farms all around the world. And in visiting all of these farms, this one trend really stood out to us, which is that despite the growth and the size of the industry, aquaculture is an industry that is still run almost entirely manually. And that's from water quality, taking water quality readings, to writing down the data, to looking and inspecting the health and growth rates of those animals, and to feeding. And when you have large amounts of manual things going on at these farms, it means that each farm operates differently. And when each farm is operating differently, it means that the industry as a whole hasn't been able to build best practices. And when you don't have best practices, you don't have predictability in what you can do. And so the next place we looked is at the survival rates and comparing, looking at aquaculture and comparing it to other animal husbandry industries. And if you look at those, they've been pretty figured out, at least in terms of the survival rates and the predictability aspects. But when you start raising animals in water, that survival rates, they start to drop. And in shrimp especially, if you talk to any shrimp farmer, they'll say that 71%, it's pretty volatile. Sometimes you're a lot lower and sometimes you're a lot higher. And so we went out and we talked with a lot of farmers and we said, why is it? Why is it 71%? Why is it so low in shrimp? And they said to us, well, Zach, it's complicated, literally. The problem is that when you're raising an animal in water, there is 10 times more things that could impact the growth rates, the health, the survival rates, the feeding rates of those animals than when you raise them in air. And so I grew up in Silicon Valley. I come from there, so our company is there. And when we see something that's very complicated, our first instinct is to go and collect more data. And that led us to our first kind of core principle that we founded as a company, which is to achieve predictable yields. And we believe you need predictable yields to have sustainable and responsible aquaculture. To achieve predictable yields in aquaculture, farmers need better tools to collect their data. And so we went out and looked and said, what tools are available? And this study really stood out to us. This is a very interesting study done by the USDA in 2005. And basically what they asked themselves is they said, hypothetically, if every catfish farm in the US, every pond, was monitored continuously and automatically, what would happen to the industry? And so what they discovered, or what they theorized, is that the industry would have been 2.5 times more profitable. So that's a lot of cash left on the table. And they said that 1/3 of that money, that lost profit, would come directly from not catching low dissolved oxygen scenarios and those animals dying. And then the other 2/3 are kind of these intangibles, the indirect qualities of poor water quality. So that's things that lead to poor food conversion, poor growth rates, or high susceptibility to disease. So we looked at this and we said, wow, okay, if these economics are true, this doesn't jive with all of the farms that we've been visiting because they're not using this stuff. They're still offline and manual. And so we started asking farmers, and we've now talked to hundreds of farmers. Every farmer we talk to, we ask this question. And we say, why are you not online? And the answer is that it always comes down to the sensors. The problem with water quality sensors is that they are made by sensor companies. That makes sense. But the problem with water quality sensor companies is that they serve a bunch of different verticals. And the main two verticals that they serve are wastewater and laboratories. And the people who work in wastewater and laboratories, the people who make purchasing decisions, they care about one thing above all else. They care about precision. They don't care about price, and they don't care about labor because they have incredibly highly skilled labor that can maintain those sensors. And so when an aquaculture farm sees a solution like this, they say, okay, it's really expensive, and my labor can't keep it calibrated, cleaned, and maintained, so I can't run my business off of it. And so to us, this brought us to our second kind of core principle as a company, which is that to bring aquaculture online, to make it predictable and thus sustainable and responsible, we need innovation at the sensor level. And we need that innovation to be 100% focused on the needs of aquaculture farmers. And so that's exactly what we're doing. With OSMOBOT, we are combining two of the most cutting-edge sensing technologies that are out there today. The first is optical sensing. If you've ever used an optical dissolved oxygen sensor, you've used this before. Basically, how it works is that you take a dye that is sensitive to the water. It will either change color or fluoresce, depending on what's going on, and you suspend it in a plastic. And that plastic, we call it a patch. And so we put multiple of those patches for different parameters on our sensor cartridge, and that sensor cartridge faces out into the water. And on the inside of the sensor cartridge, we have a camera. And so we actually take a picture of all of those patches and then process the data to spit out a reading. So it's pretty neat, and what it allows us to do is a few cool things that other sensors can't. The first is that we have one sensor has all of the key parameters that farmers care about. So today that's dissolved oxygen, pH, NH3 ammonia, and temperature, but it's an optical sensing platform, so we have a lot more planned for the future. The second is that it's much simpler to maintain. Instead of with traditional probes of needing to pull them out of the water, visually inspect them, wipe them off, recalibrate them, and doing that on a weekly basis, with OSMOBOT, not only can the system look through itself and say, hey, I'm dirty because I have a camera and I can see it, But when it comes time to replace that sensor cartridge, all the farmer has to do is pop out the old one, put in the new one, and the system automatically sees the QR code and will self-calibrate. And then the final thing is, because we are innovating at the sensor level, we are in control of our full technology stack. And so what that means is that we're in control of our costs. And so we know that cost is a huge barrier to getting this industry online, so we've really focused on reducing those. So our sensor and monitoring system costs 90% less than what is equivalently on the market today for these farms. So on top of our hardware, we have our software. So with that, farmers get the ability to transition from using a notebook, from using Excel, to start managing their farm in the cloud. And so OSMOBOT automatically records their water quality parameters, but they can enter things like feeding rates, growth rates, survival, things like that. And we can start doing some basic analysis to start uncovering some of those best practices. They can, of course, get 24/7 notifications the moment that something goes wrong, so that they can take action and start boosting those survival rates. And then finally, what's kind of most exciting for us, because we're nerds, is that our sensor is the first of its kind to have the ability to actually get better in the field, not worse. This is because we're using computer vision. There is this new, relatively new technology that's used with computer vision called deep learning. And how deep learning works is basically you show a computer thousands of pictures of roughly the same thing. In our case, it's a sensor cartridge. In self-driving cars, it's roads and things like that. And you say, okay, computer, what patterns can you recognize? And that allows the system to learn over time, because computers now can be much better at pattern recognition than we can. And so not only does that mean that our sensor can actually get better in the field over time with every reading that we take and get more accurate, more precise, be able to last longer, but it also means that we have the potential to look at some new parameters that other sensors can't. One of those that we're really excited about is watercolor. And looking at watercolor and turbidity with deep learning and computer vision, what can we discover about what's going on biologically in the pond? Can we detect a blue-green algae crash or something coming like that? We don't know, but the potential is there. So I've taken this story around the world and talking with farmers, and I'm pretty pleased to say that it's resonated with them in innovating at the sensor level. We've signed over 45 pilot agreements with farms around the world. This is from small mom and pop farms here in the US to some of the largest, most professionalized farms in the world. It represents a very large number of units and potential sales for us in terms of ARR. We charge both an upfront fee for the hardware and then an annual fee for the replacement cartridges. In addition to that, we do no paid advertising, and we get 1 to 2 inbound emails a day from our website saying, hey, I found you, I want this. That tells us that farmers are looking for this. And the final thing is, I actually just returned from another competition. I was down in Ecuador, in Guayaquil, about a week ago, as a finalist in an industry competition for innovation. And we actually won, which was awesome. And so I actually need to update the numbers on this slide, because we've been able to generate even more interest from there. So I'd like to conclude by zooming back away from our product and looking at aquaculture as a whole. There is no silver bullet to end overfishing. But I would argue that aquaculture is the biggest lead bullet that we have, given its size and given how quickly that it's growing. This is another very famous graph from aquaculture. And it basically stipulates that aquaculture needs to double its output by 2030 if we're going to meet global protein demands. And in order for us to double that, it's going to need to do so sustainably and responsibly. But in order for farmers to act in the most sustainable and responsible manner, they need to have something that's predictable. Because when something's not predictable, that's when you start hedging as a farmer. That's when you use antibiotics to try and protect against a disease or something like that. And so in order to create predictable aquaculture, I want to go back and finish with our core 2 beliefs, which is 1, is that farmers need better tools to collect their data. And 2, they need those tools to be 100% focused on them, and particularly at the sensor level. That's exactly what we're building. We're very excited to be bringing pilots here and to our first country in Ecuador in 2019. Thank you very much, and I look forward to your questions.
Zach, great job. Thanks. So, just a question, the sensor, if it's in a pond or a thing, is it fixed in a position or is it floating? How does it move around and what's it photographing?
Yeah, so it's on a buoy.
On a buoy?
Yeah,
Okay.
and so the shrimp ponds are about 1.5 meters deep, so it
Right.
hangs in the middle of the water column.
Okay.
And that's on larger ponds. In smaller ponds, you can just tie it out to a pole in the middle of the pond.
Got it. But so you're sort of getting a sample all around the pond, not just
No,
one?
there's enough movement in a
Yeah.
pond.
Okay.
In very large ponds, we say put it in the outlet because that's where the water quality will be worst,
Got
or
it.
in the feeding zone because
Okay.
that's where the oxygen will tend to drop the most.
Got it. Ann?
Hello. So you've got a number of LOIs for pilot projects. Are these paid pilots or?
These
okay.
we only do paid pilots. We find that if you give something to someone for free, they don't use it.
So how will the $100,000 of an ocean exchange award, what does that do or what does that bring you to?
It allows us to accelerate our path to those pilots. We have some DFM things that are coming up with transitioning from our prototypes now into them. So being able to cut tooling for some custom plastics to be able to get there will make a big impact on our ability to deliver on those and get these into the field.
Thank you.
Anything else? Anyone else? Here comes one.
Just offhand, how big is it? Is it big, small?
It's about that big.
And is it powered? So if you're hanging in a pond, you have electricity going to it too. So it's not a transmitting type thing. It's going through a line to provide the data.
So
Fiber
right
optic?
now it's powered. We're designing it eventually to run off of solar, but there's kind of two things that we're not addressing right now. So we're not addressing power and we're not addressing connectivity. It does Wi-Fi or cellular, which is not that scalable. We're focusing on the sensor, which is the really hard part. The other parts have been solved, and so we'll be able to integrate those later. And there's a lot of things we can do, even just powered, working in hatcheries and nurseries and things like that to begin with.
So hardwired cable. So how is it receiving information? Is it a coax or is it?
It's Wi-Fi or cellular, depending.
Oh, sorry. Okay, got it. But it
Yeah,
has to be
depending on the
powered.
region. Yeah.
Okay.
Okay, anyone else? So when we're at the round table, Zach will be at his table next door, so if you have any more questions that pop up, you can come get them. Zach? All right, thanks.
Thank you very much.